Hello my dear friends, welcome to the Renewable Energy Study Group. In the today's session, we're going to see the calculation of monthly energy generation in the Excel sheet. Basically, in the earlier session, we have seen the monthly energy generation in the PV Watt software. Basically, the energy generation is nothing but whenever we are installing a solar power plant of any size, ranging from the first kilowatt up to the 100 or the 500 megawatt level of the particular project. So before installing any solar project in terms of kilowatt, we have to estimate what amount of electricity in terms of kilowatt hour the solar power plant will going to get generated. Because whenever we are estimating an profit and loss account in the particular, when we are doing an investment in a solar sector actually, so in that we required what amount of forecasting that we are getting from the solar power plant. There are basically the two methods, one the manual method of energy generation or the energy calculation. Month wise also we can calculate manually with the help of the Excel sheet, and the year wise also we can calculate over here. And whenever we are calculating the final balance sheet of the particular financial balance sheet, so in that cases actually we required to consider this particular data over here. So basically how we calculating the monthly energy generation or the energy yield with the help of the manual Excel sheet is that we just prepare such kind of a format in the Excel sheet calculation. Out of the first table or the first column is the month over here, that is from January up to the December month. We need to calculate the particular energy yield. Again, the number of days in the particular month we have to select over here. January is carrying 31 number of days, February is carrying 28 number of days. So likewise manually we just putting over here how many number of days are there in a particular month that we are selecting over here. Then in the third column we have to select the number of panel in our particular solar project. So let's say if you are going for the 10 kilowatt of a solar project, we required approximately 30 to 32 number of the panels as per the selection of the utility scale solar panels actually. So we just go for the 10 kilowatt of a solar project. So basically there are number of methods are there to calculate the number of panels. In my earlier video also you can able to see for 10 kilowatt of a capacity how many number of panels we required, and we were calculating this number of panel with the help of a formula. Then we decide how many panels will required to connect in the series combination and how many strings we required to connect in the parallel combination. In the earlier videos you will get this particular information in the channel over here. So basically we just select the 10 kilowatt of the solar installation capacity will require approximately 30 to 32 number of the panels. So we select over here, let's say the 32 number of the panels will required for 10 kilowatt of the solar installation capacity for the residential scale solar power plant that we were installing over here. So we just copy this particular 32 number up to the December month. Simply you have to just select this particular corner of the cell in the Excel sheet and just pull this particular corner up to the December month that we have been noted down over here. So basically this 32 number of the panel value will directly getting copy over here. Again, the fourth column is saying that the panel capacity that we were selling. Basically there are number of the solar manufacturers are there currently in the market. The leading manufacturers like the Vikram Solar, Vari Solar, Tata Solar Power Plant, likewise, they have provided their data sheets for whenever they were manufacturing the particular solar panel. Like there are number of cells are there like a polycrystalline, monocrystalline, monostandard, monoperk, bifacial, half cut type of solar cell. According to that, their capacity is getting varied over here. For this particular case study, we are going to select the 325 Tata Power Solar particular solar panel. You can select any of the solar panel. Just remember what is the maximum peak capacity of the solar panel is having. So let's say if it is having the 325 watt peak of the maximum solar panel capacity for the Tata Power solar module that we were selecting. Same module capacity we have to just copy up to the December month. Just select this particular corner of the select row and up to the December month just copy this particular value over here. Then in the basically fifth column we have the average daily GHI value. GHI value called as a global horizontal irradiance. Global horizontal irradiance, in the earlier videos also I have been explained what do you mean by this GHI value. It has been the combination of direct normal irradiation and the direct horizontal irradiation that is falling. normal solar irradiation, horizontal diffuse solar irradiation, the combination becomes the GHI value, which is global horizontal irradiance. There are number of websites through which you can calculate what is the global horizontal irradiance value for any of the site that you are calculating the or installing the solar project. So let's say this data is for the Mumbai region district. So we can calculate this value either from NREL website, rather we can calculate this value from Meteonom website, rather we can give this value from the particular NASA database over here. This we can get from the Google also. Just copy this particular value, write a particular district name, and for the district name find out these values in the Google and just put this value from the December to this January to the December month. Every month in the particular location, the GHI value which is falling on the site is changing actually, site to site, and day by day it is changing over here. Just note down this value over here for the subsequent calculations over here. So basically take an average of it. So average we get 5.87 kilowatt hour per meter square per day. The unit of GHI is kilowatt hour per meter square per day. According to that, we could do the subsequent calculation in the Excel sheet over here. Next thing is the final power output of a solar module. Basically the final power output of a solar module is what? After considering the number of derating factors, because whatever the module manufacturer is giving us, that is 325 watt peak, that is the main capacity of the solar panel. But actually when we say in the practical environment, there is an increase in the temperature is having, there are the soiling losses are having, there are the PID losses are having, light induced degradation losses are having, cabling losses are having, much of the losses are having actually. So we have to consider the particular derating factor which actually more affecting over the panel capacity. Then we can estimate 325 watt peak of a solar panel will generate practical cases this much amount of the power over here. So what will be just over here, like say the equal to we just write. Whenever we are writing the formula in the Excel sheet, we need to write start with the equal to, then the bracket. We choose the panel capacity which is the 325 watt peak multiplied by, we have to choose basically the derating factor. The first factor we will choose it as the soiling factor. If any soiling is depositing over the solar panel, let's say the 5% losses are happening over there. So we take 95% efficiency, which comes 0.95 multiplication factor. 0.95 resembles to 5% loss of the particular due to the soiling losses. So 0.95 just multiply by derating factor multiplied by, we take here manufacturing tolerances. Manufacturing tolerances consist of LID losses, PID losses in the particular solar cell. So we take 5% of the manufacturing tolerance loss, which resembles to 0.95% of derating factor. Also we are multiplying by the temperature increasing factor. As the temperature goes beyond 25 degrees centigrade, per degree increase in the temperature, there has been the decrease of the power output up to some percentage. Module to module wise, this temperature coefficient value is getting increasing or the particular changing over here. So whenever we select a data sheet of a module or a solar panel, in the data sheet it has been mentioned over there. So basically approximate we take 5% of the temperature losses over here. So we just multiply by 0.95 and we just complete this bracket over here. Divided by 1000. So we will get the value in terms of the kilowatt peak over here. So we are getting over here 0.28 kilowatt. So this much basically the final power output we are getting after considering the derating losses due to the manufacturing tolerances, soiling losses and the temperature derating factor over here. So just copy with this value up to the December month, simply put over the row and just copy this value up to December month over here. In the 7th column, it is written that actual DC energy output from the solar array. It means that if we are combining 32 number of the solar panel, what will be the output in terms of kilowatt hour the solar array is giving actually at the DC side. So we can calculate this by this formula equal to, in a bracket we can take what is the output we are getting from individual solar panel in the practical situation multiplied by what will be the number of solar panel we are choosing in the array. So we select the particular cell multiplied by what is the basic GHI value, that is horizontal global horizontal irradiance value of the particular site over here. So what we have done, final power output again the GHI value multiplication and the number of panel multiplication, and enter. So we get 56.18 kilowatt hour is the actual DC energy output from the solar array. So we just particularly just pull this value up to the December month. So we came to know in the month of July the value is 37.45. In the month of January it is 56.18 actually. It is because in the global horizontal irradiance value which we are getting from solar radiation in July, which is typically a rainy season in India actually. So that is why the solar radiations are lesser, and thus it is reflecting the actual DC energy output that we are getting from the solar array over here. Then we are going to proceed for DC input at the inverter. So when we are giving the power from the combiner box up to the inverter, we were using the DC cable over here. Considering that there is a 3% losses are there due to the DC cable, so we just write this formula equal to in a bracket the actual DC energy output from solar array in terms of kilowatt hour multiplied by, we just multiply by 0.97, which is the derating factor resembles to 3% losses due to the DC cable, and enter. So here we can calculate up to the December month. We just pull this value. Subsequently changes has been happening per particular month to month basis over here. We'll go to on the 9th of that column. Actually it says that AC output energy from the inverter. So whenever we are giving the power to the inverter, from the DC to AC conversion losses has been happening over here. So we can say we can consider over here the inverter efficiency, which resembles to the DC to AC conversion losses. So equal to in a bracket DC input that we are giving to the inverter in terms of kilowatt hour multiplied by what is the efficiency of inverter. Just see the data sheet of inverter that you are choosing. According to that, most of the inverter is having 96% of efficiency. So you multiply by 0.96, which resembles to 96% of efficiency of inverter that we were selecting for residential scale solar project, and enter. So from this you can calculate up to December month. Just pull this value on the road side. Subsequently changes has been happening in the month to month wise over here. 10th column we see the AC energy delivered to the grid actually. So whenever the energy is passing from the inverter, from inverter up to the particular metering panel or the switching panel, actually customer switching panel, we were using the AC cable, which is a AC armor cable we are using, and we were considering that there is 1% losses will be happening for the AC cable. You can change these losses according to the site and what cable that you are selecting for the subsequent application. So in this case study we select 1% AC cable losses. So the AC output energy from the inverter in terms of kilowatt hour multiplied by 0.99, where 0.99 resembles to 99% efficiency or the 1% losses due to the AC cable, and enter. Subsequently we select this particular column and just we pull up to the December month, and simultaneous changes has been happening per individual month according to this GHI value. And last column, 12th column, we see monthly AC energy yield. It means that month wise how much amount of unit our 10 kilowatt solar power plant will generate actually. So this we can calculate up to equal to in a bracket what AC energy we are delivering per day actually. So it is 51.79 for January month. So we select this particular cell multiplied by how many number of days are there in the particular month. So the January carrying 31, February carrying 32, select the particular cell actually and say enter. So it says that 1605.40 this much kilowatt hour has been generated in the January month. Subsequently just pull this particular cell up to December month and you came to know what is the monthly energy generation has been there for the month wise analysis over here. And lastly we just write sum of all these parameter over here. So we just write the formula what is the yearly energy yield is getting generated. So use the command of sum command equal to sum in a bracket. So basically equal to sum in a bracket, and we just copy this particular cell up to December month and bracket complete over here, enter. So we get 17,572.81 kilowatt hour per year of units has been generated by the 10 kilowatt capacity of the solar project. If you want to do a graphical analysis of it, just select this particular column, that is monthly from January to December, and just go on insert and select the graph, that is a 2D graph, 3D graph, whatever the graph you be comfortable. So I'm choosing over 2D graph over here. So it will come over here, that is from 1 month, that is January month, up to the December month, how the energy yield variation will be there for the 10 kilowatt of the solar project. Just click on this any one of a column, right click on it, add data labels over here. So we came to know in the January month we are creating 1605 units, March month we are creating 1837 units. Subsequently there is a July, August, September, which is a rainy season in India. The energy yield will be lesser. Again in the winter season energy yield will be higher over here. So likewise we can analyze month-wise energy generation by the solar power plant with the help of the Excel sheet. Fine, thank you for watching the video.